All right, I hope everyone settled down. Our speaker for this session will talk about software security and slippery slopes, how to elevate an entire ecosystem at scale. Let us welcome Dustin Ingram.
Thank you. So I'm Dustin. I'm on the Google open source security team. So the mission of that team is to make open source software that Google and everyone else uses more secure. I'm also on the Python Software Foundation board of directors, where I help ensure the long-term success of one very big open source Python project you've probably heard of, Python. I'm also one of the Python package index maintainers, where I help ensure the long-term success of hundreds of thousands of teeny tiny Python projects, many of which you've never heard of. And also I'm on the technical advisory committee for the Open Software Security Foundation. This is new, where I help guide the success of the next generation of open source security technologies. So this talk is about ecosystem security. My focus at Google is to kind of think about how to increase adoption of security improvements across many open source ecosystems, including Python, but not just Python. And as a maintainer of PyPI, I also really deeply care about making sure that the Python ecosystem is safe and secure for all our users. So I definitely care about how one would go about elevating the security of an entire ecosystem at scale. But you probably don't have those same responsibilities. You probably don't have that job either, and that's fine. But why do I think you should care about this? So here's what I want you to get from this talk. First, why this is hard. So I want you to understand what are the actual challenges that make this hard to do. Second, I want you to understand why some churn is necessary, and I'll explain what I mean by churn, why I think it's necessary, and how I think we should deal with it. Also, I want you to understand how security can increase sustainability. So there's more of a relationship between these two things than you might actually expect. And finally, I want you to understand how you can help. And this isn't just, let's pitch in on some open source projects together. There are actual ways for you to help when you think about security. Overall, I want to give you an insight into how these things change, how we think about security in our ecosystem, and all the trade-offs that exist at each point. Because everything is a trade-off, right? There are trade-offs in every decision. There's never just one best solution, right? We're always balancing between two choices. So, part one, why this is hard. Security is hard enough on a small scale. So some of you might be familiar with implementing or adopting security changes, procedures, or practices on your teams or maybe in your organizations. And my guess is that those were maybe somewhat challenging. If you were implementing those changes, maybe you had to articulate the problem, get sign-off that it's worthwhile, make a plan, check it twice, get everyone on board, convince all the holdouts, announce it, roll it out, beg and plead the holdouts. It's not easy, right? If you were the person adopting the change, you probably had to deal with a really confusing change that nobody told you about and probably broke something that you were responsible for. So these things are hard on a small scale. These things are extremely hard on a large scale, especially on an ecosystem scale. Why is that? So one reason is that users don't ask for security, they assume it. So for example, GitHub is requiring all developers who contribute code on github.com to enable one or more forms of two-factor authentication by the end of this year, by the end of 2023. The number of people I've seen asking, pleading GitHub to make this change is basically zero. No one is asking for this. However, the number of people that are assuming that all code pushed to GitHub is pushed by the actual owners of the accounts that pushed it is basically everyone, right? That's like a base assumption for GitHub. So many times I've seen this lack of user requests held up, or lack of user requests for a security feature held up as a reason for why it's just not worth doing. The lack of requests is because users assume that proactive security is just happening behind the scenes, that they don't need to ask for it. Additionally, for those users, it's hard to work towards hypotheticals. So I think of security as a field generally as an exercise in professional anxiety and paranoia. It's preemptive work to mitigate some potential outcome of varying levels of bad that has some varying level likelihood of happening. And users are reactive. The reason they don't ask for security features is because a bad outcome is of sufficient impact hasn't happened to them yet. So we can sort of think of this as a quadrant, right? The range from low likelihood to high likelihood, low impact to high impact. So low impact, low likelihood, these things are no big deal, right? Don't worry about them. Low impact, high likelihood, this might be something like password reuse, credential stuffing, maybe phishing. So something where it's very likely it's gonna happen. Human's gonna stick their password somewhere it doesn't belong, but usually there's enough of a blast radius around a single person that it's not the end of the world. The next thing is high impact, high likelihood stuff, like leaving your S3 bucket world readable. That happens all the time. You could lose a lot of information that way. Secrets leaking that give you keys to your kingdom. These are extremely high impact, but also they're incredibly frequent. And then the last quadrant is stuff that's high impact, but low likelihood. So this is like getting hacked by a nation state, right? For the same reason that some of these are harder to address than others, they're also harder to motivate. It's not really just users, though. Here's a refrain I see from time to time from maintainers. But we haven't made any mistakes yet, where the ask is to adopt some security tool or feature. I haven't been phished yet. I haven't leaked an API token yet. I haven't included things I shouldn't in a release yet. I haven't unknowingly created a vulnerability yet. Here's a real paraphrase quote that I got from a maintainer, and this was in response to a request to automate the build and release process for a library. They said, "I've made more than 200 releases to date, and I've never made a mistake." So first of all, kudos to this maintainer. That is actually impressive. I have not done that myself. I break PyPI all the time. But is this actually a good mindset to have as an open source maintainer? What are they actually saying here? They're saying that they don't want to change their behavior, and that even if the risk is high enough, the impact is relatively unlikely, and they're probably also a little offended that you don't consider them infallible, that they might make a mistake. This also kind of fails to consider that really often our problems are not directly caused by us. We don't work in vacuums. A lot of things are caused by other people and other systems, other things around us that are entirely out of our control, perhaps, that can also go wrong. High uncertainty components in complex systems. This is another reason why this is hard. Security often requires changing high uncertainty components in complex systems. Who was at Ned's keynote yesterday? Do you know what I mean by this? People. It means changing people's behavior, especially their behavior around security. There's really, I think, two ways to interpret kind of any technical problem. One of them is that the problem is easy because people can just do X, right? We can build a technical solution to our problem, and that solution might work perfectly, and then people can just use that. Easy. The other interpretation is that the problem is actually incredibly hard because it requires people to do X. So often that the hardest part of solving a technical problem is not the technical problem itself, but changing the behavior of people around that technical problem. So, for an example, I still use a code editor that I first used almost 20 years ago, which itself was first released almost 50 years ago. And to be fair, code editors are incredibly personal tools, but for me, all of the benefit of a modern IDE has still not outweighed the cost of me changing my behavior. I'm extremely resistant to it. So there is a third thing that happens sometimes. Sometimes it's very easy. Doesn't require people at all. This almost never happens. Improvements that don't need humans to change their behavior are so few and far between. Even still, when we have the opportunity to make such an improvement that might not require humans to change their behavior, it often doesn't happen because it ends up being technically more challenging. And so we fail to take into account the cost of changing human behavior in the end when we add up all the effort that goes into a change. So there's almost always a requirement that people do X. The need to change human behavior is basically inevitable for almost every technical problem. And I think this is especially true for software security because, let's be real, most software insecurity comes from those pesky humans. This is called churn. This is the part where we require humans to change or make a change, meaning any work that you have to do that isn't directly related to your outcome. So an example of churn might be adopting a dependency updating tool on your codebase and merging version bumps for new releases, or adopting a vulnerability scanner to run across all your dependencies and alert you when vulnerabilities when they happen. Or maybe churn is like reaching from your keyboard for just a second to touch a little USB dongle, I don't know. Okay, so part 2, why some churn is necessary. So we've established that churn exists, but let's figure out why it's necessary. So sometimes security can happen by default, and it's great when this happens. So one example of this might be like auto-revoking credentials on a token leak. So right now, if you put your PyPI API token inside of a commit and you push that to GitHub, GitHub would immediately detect it, alert PyPI, and PyPI would immediately revoke that credential, probably like within milliseconds of you pushing that commit. And this requires zero change to human behavior to get this increased security. Humans can and do continue happily sharing their most sensitive secrets on GitHub, but they're protected. There's just significantly less fallout to deal with, and they don't have to do anything to get that benefit. But usually security does require some change. Usually you gotta do something to get something in return. So okay, if churn is inevitable, what should we do about it? So first, here's some things that I don't think we should do. So one of these things I think we shouldn't do is assume we can just magically get people to do things that are impossible. We can't just like wave our hand and get humans to act. So maybe an example here is PGP. In a technical sense, okay, maybe it's a decent solution to the problem. In a practical sense, I think it's kind of absolute nonsense. In order to use this, we have to get a bunch of humans in a room and have them show each other their driver's licenses and special random character strings to verify their identities. And then also those humans can never lose those special random strings of characters, ever. Okay, good luck. The other thing we shouldn't do is shift complexity onto people. And I'm talking about stuff that's not strictly impossible for humans to do, but it's not always the most ideal thing for humans to do. So, for example, reading CVE notices for vulnerabilities and trying to determine if you're affected. So, okay, I find a vulnerability in some computer thing, and then the way to fix it is that I write, as a human, some long document, and then I have to have other humans read that long document, and then they have to try and figure out if it applies to their own computer things. That's madness, right? We should cut out the middleman there. There's better ways to do that. The other thing we shouldn't do is nothing. Like, we could all just give up and become farmers, but we shouldn't do that. So one thing maybe we could do is force a change via a mandate. So I work at Google, which I often describe as having like this wacky upside down alternate universe of software tools. And in this ecosystem, adoption is not won by many little small wins by convincing individuals. Because if you can just convince a couple people, very special people, you can just mandate that everybody does the same thing. So overnight, your software tool can go from like 0 users to 20,000 users just by mandate. And this works for Google because there is authority to mandate that change. So it's possible that could work for your organization as well, but it might not work because it's also really expensive, right? It requires paying people money to eat the cost of adoption, to do all the churn. And I think usually this doesn't work in open source ecosystems, usually because there isn't a central authority. So in this context, something like the Python Steering Council or a core dev team, right? They have some authority to make changes, but they have very little authority to make users use those changes, to adopt those changes, right? People are still using Python 2.7. But also because of the expense, right? If those mandating are not the ones who are paying for the expense of churn, of mandates, that becomes problematic. And I'll talk more about that in a second. And that said, though, I do think there are times when mandates are necessary, and I'll talk more about that in a sec, too. All right, so churn is inevitable. What should we do? First, as much as possible, we should minimize. This means putting the hard work in to shift as much complexity from people into the technology or the tool or the solution. And there's a few types of minimizations that are possible here. So one, we can minimize human effort through automation. So like these are like the bots that monitor your dependencies for new versions. Humans don't have to do that. Humans don't have to make the PRs. The bots do that too. All the maintainer has to do is click merge. There's still a little churn there, but we've really minimized it. Another one is minimizing the cost through efficiency and simplification. I'm not talking about like costs in terms of money here, right? I'm talking about people's time. As long as we can do things to minimize the amount of effort necessary to adopt some new thing or some change, that counts. The other thing is minimizing human time through education. If the human already has a base level of understanding about why a change is necessary, that it's not just coming out of the blue, there's a lot less context they need to build in their minds to adopt the change. I want to highlight a specific example on this, if you don't mind me tooting my own horn for a second. So we just launched Trusted Publishers for PyPI on Thursday. So this is a new way for maintainers to publish to PyPI from GitHub Actions that does not require long-lived passwords or API tokens. So this is something that requires maintainers to make a change, but we put a lot of effort into minimizing how much churn is necessary to adopt this. So the first thing we did is we minimized effort through automation. So this requires a new authentication method that involves a somewhat complex token exchange and verification mechanism. And I see your eyes glazing over already. Don't worry, it's all really nicely abstracted away from the user if you use the PyPA's GitHub action. You don't even have to think about it. We also minimize the cost of adoption significantly. Like to adopt this, all you need to do is really change like 3 lines in your GitHub workflow. And one of those is a comment. 2 of the removals are just deleting environment variables you don't need anymore, or parameters. And the other thing we did is we educated. I just told you everything you need to know about this. So you should now feel empowered to go and adopt it. Boom, you've been incepted. Okay, getting back to the ways that we can minimize churn. Another thing you can do is revolutionize. So what I mean by this is to develop a change that is so compelling that it outweighs the cost of adopting it by an order of magnitude. And an example here that I like to highlight is Sigstore. I think Sigstore is a really great example of this. So full disclosure, I am very biased because I work on this project. I created the Python client for Sigstore with some support, and I sit on the technical committee that at the OpenSSF that is the home of Sigstore. But the reason I decided to do all those things is because I found Sigstore to be such a novel and compelling solution to the problem of code signing, which solves many existing problems in our ecosystem. So I'm not going to go into full detail about what the compelling reason is and how Sigstore works. If you want that, you can watch William Woodruff's talk, Ergonomic Code Signing for the Python Ecosystem with Sigstore, where he goes into a very deep dive about this. But suffice it to say that Sigstore is a brand new way to sign and verify just about anything. But this comes at a really high expense, right? You need to adopt an entirely new set of tools for signing and verifying, or adopt a set of tools in the first place. So in this case, I would say that Sigstore is revolutionary because the cost is worth it, and continuing to invest in this as a solution is still worth doing. And if all else fails, we can incentivize. So why? Maybe the solution is really expensive to adopt, or maybe it's not particularly revolutionary, or maybe a mandate feels really heavy-handed. So instead, we can sort of put our finger on the scale in various ways. So sometimes this comes naturally, like with Trusted Publishers. The presence of this feature unlocks many other things that we can do, like we'll be able to show and verify a link between a PyPI project and the GitHub repository that created it. It's not something we could verify before. But this will only be possible to projects that have adopted this feature. So in that way, it sort of helps incentivize its own adoption. Sometimes we can add other unrelated benefits, like, for example, the PyPI 2-factor giveaway and security key giveaway. Sometimes this works, sometimes it doesn't. I know there was some drama about the security key giveaway, I know. But in this example, I think it worked because we gave away thousands of keys, and more than 37,000 users now have 2-factor enabled on PyPI. This is awesome. So with the example of two-factor authentication, why do we even do it, right? What's the point? That's part 3, how security increases sustainability. I think a lot of the arguments for security improvements usually amount to because hackers, right? It's preventative care to ensure that bad things don't happen someday, where bad things are like compromise, exfiltration, whatever. There's also common criticism for this, though, that security is like a slippery slope, especially things like security mandates. The idea is that if we keep increasing security requirements, we'll end up in some pit of maximum security where innovation is completely stifled and both maintainers and consumers just can't do anything. Ultimately, I think our goal is increasing sustainability through security. There is a cost to the lack of security. We just don't pay it when we choose not to adopt. We pay it months and years later when things happen, and we pay it with interest then. So here's an example. Think about what has to happen when just one maintainer on PyPI gets phished and their project gets compromised and malware gets published. So admins have to triage reports, they have to do investigation, they have to do public communications, take down the malware, do account recovery for the maintainer, talk to the press, talk to other folks. Like, it gets really complicated. It eats up a lot of time. So at the expense of maybe one person not taking a few seconds to use two-factor on login, this eats up hours of maintainer time that could be used for other things, and also potentially downstream users uses up their time as well. So in this case, we want PyPI to be secure and useful for all users. The goal isn't to make PyPI impossible to use. That would be counterintuitive, right? But if these are the kind of things we have to spend all our time on, PyPI will become impossible to use. Like, if I spend my entire day responding to malware and responding to people getting phished and their accounts compromised, I don't have time to build cool features. I don't disagree that software security is a slippery slope, but I think the slope is actually upwards, not downwards, like really steeply upwards. And it's because all people, they're resistant to change. And because this upfront investment in security, it's really hard to show impact for when the result is something that doesn't happen. The effect of all of this is that it's often really hard to adopt new security features. Here's another example. So maybe you've heard about the 3CX supply chain attack. So this just happened last month. What happened was attackers exploited a bug in the way that Windows executables are signed to compromise a communications company called 3CX. So this bug allows an attacker to modify any signed Windows executable to include malware, and for verification of signing, to still claim that it's legitimately signed. This bug was known for 10 years. And yeah, it sounds like a pretty big deal. It was fixed, actually, but then it was only fixed as an opt-in. Why was it opt-in? So it's because that many people that were shipping Windows executables were using this bug as a feature. So for example, Google Chrome, the installer for Google Chrome uses this bug to provide a slightly modified binary if you opted into sending usage statistics and crash reports to Google. And so when you downloaded Chrome, and when the executable was installed, it uses this bug to determine if diagnostic reports should be enabled. Like, it wasn't just Chrome, lots of people were using this. So because fixing this bug would break so many workflows, it didn't happen. For 10 years, it was opt-in. And to make things worse, when you upgrade to a newer version of Windows, it reverts the opt-in. So remember, users don't ask for security. No one was petitioning Microsoft to fix this. And sometimes users can take a dependency on a lack of security. Okay, that's enough ranting for me. Let me get to my point. So I hope that you now have an understanding about why this is hard, about why some churn is necessary, and about how security increases sustainability. What do I want you to do? First, please don't depend on bugs. This may be a rare case, but don't take dependencies on the presence of bugs, especially security bugs. While we're at it, don't take dependencies on internal APIs either, right? Regular breaking changes are difficult enough. Maintainers should be able to ship bug fixes, ship security fixes, and improvements, and have them happen by default, especially when they address security vulnerabilities. Another thing I'd like you to do is look for opportunities to proactively invest in security. So weigh the cost of adoption with the cost of if things go wrong, right? So for example, with trusted publishers, which would you rather do? A few minutes to change your GitHub workflow now, or a potential compromise if your long-lived secrets leak on GitHub for some reason? Maybe take a couple minutes to do the change. Last thing is, I want you to support sustainability. Be willing to accept a little churn when it's reasonable and when the end result is a better overall ecosystem. Maybe also trust the maintainers of your ecosystem to make decisions that have your overall long-term best interests in mind, even if they might feel just a little bit inconvenient. Okay, I want to make some quick shout-outs and acknowledgements. First, I want to thank William Woodruff and the team at Trail of Bits, who did a lot of work on PyPI, specifically around trusted publishers, and a lot of that good work I highlighted was due to them. I want to thank Sviatoslav Sidorenko, who's the maintainer of the PyPI Publish GitHub Action, for also doing a lot of great work to make that very easy to use and adopt. I want to shout out to everyone who enabled two-factor authentication on PyPI. Thank you. If you haven't, go and do it. I want to shout out to the Ghost team, the Google Open Source Security team, who funded much of this work, funded the security key giveaway, funded the trusted publishers work. And finally, I want to give a huge thank you to PyCon staff and everyone else. As usual, they really deserve your thanks as well. So please let them know you appreciate what they're doing. And thank you to all of you as well for listening.
Thank you so much for the insightful talk, Dustin. Since we still have a couple of minutes, if you have any questions, you can come up here to the mic stand.
Let's do, I'm going to cut it off now, and then we can do hallway track. And then also I should say there is a open space at 4 o'clock downstairs on packaging security for maintainers. If you're a user, you might actually want to attend this as well. I'm sure we'll be talking about a lot of related stuff. So please come and check it out. Chat with me after this or out in the hallway. I have Ghost Team stickers if you want this little guy on the sticker. Thanks.